So let's just recall how we can find our empirical probability or the experimental probability of any particular event. So we know that the experimental or empirical probability can be found out using the help of this particular formula, which is nothing but the probability of getting an event E, which is nothing but is equal to number of trials in which the event happened divided by the total number of the trials. So using this particular experimental probability formula, we can able to find out the probability of an experiment which can be repeated many number of times or several number of times. But we do know that whenever a particular experiment is repeated many a times, there should be a limitation for it as well. For an instance, if I'm talking about launching a satellite and finding out its empirical probability of getting a failure during the launching or in the launching, so such type of the experiments do have a limitation in the repetition. We cannot repeat such an experiment because they could be expensive or there must be other reasons as well. So for this reason, in order to take such an experiment, we can just assume the assumptions rather than taking the particular repetitions. Means we can avoid the repetitions and we can follow the assumptions rather than doing it many a times. And for this reason we already have taken an assumption that we are taking the outcomes of the events as nothing but equally likely. And this is all about our next probability, which is nothing but theoretical or classical probability. So the theoretical or the classical probability defined as the probability of an event E, which is nothing but is equal to the number of the outcomes favorable to E divided by the number of all the possible outcomes of an experiment. And always note that we are taking the assumptions over here, and the very first assumptions should be like the outcomes are equally likely. The outcomes are equally likely is our very first assumption which we are taking for this approach. So the theoretical or the classical probability is nothing but defined as the number of the outcomes that are favorable to E divided by the total number of the possible outcomes of an experiment. So let's just see an example which is related with the theoretical or the classical probability. Theoretical or classical, it is one of the same thing. So always remember number of favorable outcomes to E, number of outcomes that are favorable, or we can also say the number of favorable outcomes to E, and divided by the total number of all the possible outcomes. So let's just see an example for it. So let us suppose if I'm talking about the example number 1, it is find the probability of getting a head when a coin is tossed once, and also find the probability of getting a tail. So let's just find out the probability of getting a head and a tail. So let us suppose if I am starting with if we are talking about tossing a coin, then definitely the outcomes are equally likely. So let us suppose if I am taking the probability of getting a head or and a tail as nothing but the events E and F. So let us suppose let E and F be the events of getting a head and a tail in the toss of a coin. That is, let us suppose if I'll write it in this manner, E is nothing but getting a head, and F is nothing but getting a tail. Now let's just find out the probability. We know that there are the two possible outcomes only, as we know that the total possible outcomes are only two, that are nothing but, that is either head or a tail. So let us suppose we are talking about the probability of getting E. Probability of getting E should be is equal to number of number of outcomes favorable to E divided by the total number of outcomes. So this would be nothing but the number of the outcomes that are favorable to E. We know that getting a head in a toss of a coin is nothing but only one, because head can come up only one time, and the total number of the outcomes are two, because either can head comes up or either a tails comes up. So it means the probability of getting a head is nothing but half. The probability of getting a head is nothing but half. Now let's just talk about the probability of getting a tail. So it means that probability of F should be is equal to the number of the outcomes favorable to F divided by the total number of outcomes. So this would be number of outcomes favorable to F. F is nothing but an event of getting a tail, and we know that in toss of a coin either we can get a head or either we can get a tail. So there is only one tail in the outcomes. So this would be 1 divided by the total number of the outcomes. We know that the total number of outcomes are only 2, that either head or tail. So this is 1 by 2, and hence the probability of getting a head and getting a tail in a toss of a coin is nothing but half and half, using the classical approach or the theoretical approach of probability.